Welcome back to Tech With Hos. Today we are solving LeetCode 134 gas station. This problem is a favorite in coding interviews, and by the end of this video, you will understand not only the solution but the thinking process behind it. This is one of those problems that looks like it needs simulation or dynamic programming, but the ultimate solution is actually a clever greedy algorithm. Let's jump in. Here is a challenge. Imagine you are driving around circular route with a gas station. Every station gives you some gas, but it also costs gas to drive to the next station. Your task: find the station where you can start, complete the entire circle exactly once, and never run out of gas. Sounds simple, but here's why many candidates struggle. They try even starting station, they simulate the whole trip again and again. They end up with an off n square solution. The interviewer, however, expects a lot and linear time complexity or n solution. So how do we find it? Let's build the intuition. Let's see the problem statement. We're given two arrays, the gas and the cost. The gas and the cost. The gas is gas available at station I, which means gas I means the gas available at station I. The cost I means gas needed to travel to the next station. So your car started with an empty tank and returned the starting station index if completing the full circle is possible. Otherwise, return -1, we return it minus. So if it is exists a solution, it is guaranteed to be unique. So for example, we're given the gas 1, 2, 3, 4, 5, and the coast area is 3, 4, 5, 1, 2. So the output, can you find correct starting station? That's exactly what we will learn. So we start from this index and it will come to this place. So it's the final solution, or which means the guaranteed index, which means the 3. So the answer will be 3 for this one. We'll see on the visualizing process. It's easy, I think. Let's see the visualization process for this problem also. So the gas station grid algorithm explained visually. We'll see it, but first let's understand it. Like uh, this one. So a rotary planner fast station, it gives you as like it give you gas, but the drive there costs some too. So can this complete the circle? Mm-hmm. Let's see how. And the problem statement is asks it will give you a gas array and cost, and there's a circular road also, and the final value is 13, which means the goal, what we want to achieve at final. So in a station arranged in a loops, yeah. So and return the starting gas. That's our goal. So the starting gas station index. If the car completes the circuit without running out of fuel. So if no such starting station exists, which means uh, if no gas station index does not complete the circuit without running out of fuel, which means we return -1. So this is probably what ask is for us. So there is a brute force approach for every station, but actually it going to the time complexity is n of n squared. So mm, there must be a smart way we need to think about all of that. So why the greedy jump work is so uh which means if starting from station 0 fails before reaching station 3. Yeah. So the station 1 and the station 2 can never be valid because it fails at station 3. Now start with station 3. So 5 verbal drive the algorithm, yeah. So the gas, the cost, the gain, the fuel, the current start, yeah. So the station, the gas, the cost, the gain, and the fuel. So we can single pass keep running snapshot of every variable. So there's 0, there's 1, there's 3 for again is the gain has become -2, and the fuel becomes -2, and the start is 0. So after that, at index 3, it becomes good. So through walkthrough, we can see this one at visualization process. I think this one is pretty simple, and going to this one, I think uh why restarting after failure works? So why restarting after failure works? Because all the failure out, so fail goes negative. New successful route, station new start, station 4, station 0, station 1, and station 2. It is not fail, so the field becomes good as a time. So the algorithm, this is algorithm part. So starting because if you don't have uh, greater gas, the sum of the gas not greater than the sum of total cost, it doesn't give a sense to be a circular or to give a circular. So for that matter, we turn -1. This is a good condition at first time. Then traverse the array and calculate the fuel. And if fuel is in zero, we the fuel becomes zero and the starting becomes at index I+1. So we return finally after the continuing the loop, we return it. So the set, this is the problem that we need to focus. So I think the problem expanding the visualization process, I think it's easy. Let's see the time complexity and the space. Also, the brute force, it becomes off n square because we are checking every possible uh, uh, time, so every possible station. So that's it's not a good because the time complexity is of n square, but the space complexity of 1 because we didn't use an extra space. But the greedy optimal solution is of n, so we only loop at 1, so that's it of n, and the space complexity becomes of 1 because we didn't use any extra space. So for this greedy way, we can achieve a greedy solution. For this one is we can achieve a good timing. So the greedy solution is better. As always, I use Python for this problem. I think let's get into the implementation side. So I think for this problem, I use Python. So the solution is easy, but at first time for me, it's being hard because I used the brute force solution to work. But when you see this efficient solution, the second time is becomes easy. So let's get into the implementation side. So for first, we need to check if the sum of the gas is less than of the sum of the cost, which means total gas is smaller. There is no possible answer. As we said, we return -1. So if sum of gas is less than sum of cost, we return -1. So after this, we need to initialize the start and uh, the start and also the fuel. After this one, both of them are initialized with 0. So the start is for storing our current candidate and also the fuel tracks the remaining gas while we're traveling. So we need to iterate through the loop. So now we iterate once. So for I in range of lane of gas. So after this, we need to calculate the fuel. Fuel plus is equals to the gas of the I minus the cost of the I. So at that station, and we need to check the fuel becomes negative. At this position, we need to move the starting point. So fuel becomes if fuel less than 0, it's negative. If it is negative, the start becomes I+1. Sorry. After this, the fuel comes to 0 and it goes to through rest and continue. Finally, we return the starting station. So return it the start. That's it. Let's check it. It's accepted. Let's submit it. Yeah, accepted. And that's it for today's problem. If this video helped you understand the idea or if give you some intuition, give it a like, subscribe. It helps the channel grow. So remember, don't just memorize a solution. As always, learn the thinking behind them. That's what helps you solve new problems with confidence. I'm host, and this is Tech With Hos. Thanks for watching. Keep practicing, and I'll see you in the next video. Thanks for watching.